But the one that was asked about was number 8 on this study guide, if you guys would like to follow along. If you don't want to follow along, that's fine. I just need you to be quiet and working by yourself if that's the case. So Nathan, it was this one, the Jerome and Sarah one.
Yeah.
Okay. So we have the dot plots show the number of video games played in a day by 2 students. Select all statements that must be true. So when it says select all that must be true, what does that mean? There can be more than one. Sometimes there is just one, but you have to evaluate every single option before you. I will say, like when we grade the test for the select all, make sure you only select it if you're confident in it, because if you pick one and it ends up being a wrong selection, you do take away. Okay, so you need to only select the ones that you're sure of. Now for this one, the mean and median values, and these could be shuffled, so don't just blindly copy me. But it says the mean and median values for Jerome's data are about the same. So just look at Jerome's. How do I know if the mean and median will be the same, other than just putting it in a
The same.
No. Did I hear the word? Okay, so if it's symmetric, the mean matches the median. Is Jerome's data symmetric? No, so I'm not gonna select that one. You could put it in the calculator, like you could see all the dots and compare, but that might waste time on your test. That might waste time on your test. So like the more concepts you just know, the better. So like that one I don't need to put in my calculator to know.
But then the second one's wrong.
Well, the mean and median values for Sarah's data are about the same. Would you say that Sarah's data is symmetric?
Well, no, I
Is it mostly symmetric?
Yes. Yes.
So when it's almost completely symmetric, we're still gonna say like the mean probably matches the median. And it says about the same. So that phrasing also kind of lends itself to be like a little bit off. But Sarah's is mostly symmetric. So we would say her mean and median are about the same. So we are going to select that one. Now we're talking about standard deviation in the next one. What does standard deviation tell us about a data set? How spread out it is. So is a high standard deviation more or less spread out?
More.
So whose standard deviation looks higher, Jerome's or Sarah's? Whose looks more spread out? Jerome. Well, Jerome. I would say, I mean, you can also put in the calculator and compare. That's the good thing about dot plots, at least. But Jerome's, I would say, is more spread out because Sarah's data is all clustered around the mean. So like my mean and my median are about the same in Sarah's, and my data is clustered near it. Whereas Jerome's, his mean is probably like closer to here, and the data spread away from it. So I would actually say that Sarah's standard deviation would be lower. Again, we could check, like if we want to make a note on our test and say like go back and check the standard deviations of both, then we'll do that. But I'm just gonna select it for now because bell shape tends to be less spread out compared to skew. All right, so we're gonna go with that for now. Then it says the median values for both students is about the same. What would you estimate Jerome's median to be?
Oops.
Jerome's.
1.
Around 1. What about Sarah's? So I'm gonna go with they're not about the same. Like relatively speaking, 1 and 3 are pretty close, but there's only spread over about a few numbers. So we're gonna go with that they're not about the same for this data set. I'm not gonna select that one. It says the mean values for both students is about the same. That one I might actually want to check for both because Jerome's being skewed on this side, toward the right, these numbers are pulling the mean in that direction. So it could be that their mean is the same as Sarah's or at least close. So that one will actually probably check in the calculator. So I made a note to check it. That's what I'm going to do. It says if Jerome stayed home sick from school on Tuesday and played 10 hours, this would affect the mean value for him more than the median value. So let's see.
Wait, quick question.
Yes.
Like, how would we know?
And
I'm sorry. What did you say? He's asked for 60.
I don't think that part matters
Okay.
because these dot plots are how many hours of video games played by students. So they're saying if Jerome decides to play for 10 hours, if we add that to his dot plot,
Does it say that?
if we add that to Jerome's dot plot, that would be like a point way over here. Would that affect the mean or the median more? The mean. The mean is really affected by outliers where sometimes the median doesn't even change. So we are going to select that. Now, if Sarah stayed home sick from school and played 10 hours, hers says something slightly different. It says this would affect the median value for her. That I will probably have to check. But just for Sarah only, because sometimes it changes, sometimes it doesn't, and this one says it would affect it. So even if it changes by a little bit, then we are going to select that one. But let's see. So I have a few things to plug into the calculator. And this is good practice for you to see how to plug things in the calculator. You will have Desmos on your test, but remember, we cannot help you with it. And actually, I'm going to do J for Jerome. And he had 5 zeros, 4 ones, 3 twos. Okay, so 5, 9, 10, 11, 12, 13, 14, 15, 16. Okay, stop with the side conversations. Here's Sarah's, using S for Sarah, Anaish. But you guys see how I can transfer data from a dot plot? Maybe not a histogram, but if it's a dot plot, like you can put it in the calculator and see. Hers had 19. Okay. All right, so I said I wanted to look at the standard deviation, and you can find all of these in this functions menu right here. But just pick one of the standard deviations. We're wanting to see for this one whose is higher. So let's see, standard deviation for Jerome, standard deviation for Sarah, whose is higher. And his is higher by a little bit. So that's the one we selected is right. Hers is lower than Jerome's, so we selected that one. We wanted to compare their means, so let's compare their means. All right, would you say that their means are about the same? No, not for this purpose. If the data was like a bunch of numbers up to 100, then I might say yeah, but the data only goes from like 0 to 7, so stop with the noises. The data only goes from 0 to 7, so comparatively speaking, like these are kind of far apart, so we're not going to select this one, we're not going to select it. And then we wanted to double check if Sarah stayed homesick from school and played 10 hours, would her median change? So I'm going to get rid of Jerome's then. Let's look at Sarah's median before we add that data point. So before we add that data point, it's 3. After we add it, it's still 3. So I added the data point 10 in there. It did not change. Therefore, I am not going to select that one. So that's how you can use the calculator to check maybe some of them that are close. You could check them for all of them, but you shouldn't have to.
Like you should be able to save yourself some time with some of the things that we've talked about. So questions on this one. And again, don't just blindly copy, make sure you're picking the correct answers. Any questions on any other parts of the study guide? Yes. On the online one? Okay. The one that says about the histograms? Or is it a different number one? Okay. Shh. Okay, so we have which histogram represents this data set. If this were me and it was also multiple choice, I would try to look at where things are different. So first, I would look at the scale on the x-axis. It looks like they're all the same. Like they're not doing weird intervals, but that would be something that I look for. Like if they were doing intervals that were not even, then I would probably exclude that as an answer. You can't have an interval of like 10 numbers and the next one is an interval of 5 numbers. Is it about this? Okay, then put your hand down. So the intervals are not what's weird about it. So I would just look at what's different between all of them. So like some of them have nothing here for 60 to 61.5. So I'm going to check if there's how many from 60 to 61.5. And I see one data point there. So I'm automatically excluding B from this one. So I'm just going to kind of write it over here. B is definitely not going to be it because there's one data point between the first interval. Check the second interval. It does look like there's some differences. We have a 3, 4, and a 2, so we should be able to tell for this interval when it's 62 to 63.5. So let's see. Okay, so there's 1, 2, 3. I counted 3. Did anyone get something other than 3 in that interval? Okay, so then that's making me want to pick A because the other ones had different ones for C and D. So let's see. Yeah, it is A. So I would work smarter, not harder. I would see which ones like have differences, and then I would look at that interval. Nathan,
Um,
you put this data into Desmos? Okay. I mean, I feel like that's a bit too much work, in my opinion, but let's just see what it looks like. Devon, did you have a question earlier? Yes. Okay, what'd they do?
but
Okay, well, I put the S because I have the data up here. Like I like to organize it separate in case I need to find like other things about the data. I'll do like a letter equals bracket, type in my data, and then it's the same thing. Like I could type in the data here, or I guess I have to put a bracket first if I do that. Like it's the same thing, but I like to organize it separate so I could compare. All right, so anyway, we're gonna align it to the left. We're gonna zoom out, find our data. And the bin width, the way that these intervals are set up in this one is like 1.5. So like 60 to 61.5 is, which these are weird intervals anyway, but they're like intervals of 1.5. So I'd probably do like comma 1.5 to see what that looks like. But even then, it's kind of funky. I don't really love this as a comparative thing. I would just know that like the y-axis is the frequency, how often it occurred in the data, and match it up that way. Questions on that? Questions on others could be from the constructed response, could be from the online, could be in general. So to get the assessment grade in Math Lab, by the way, I need to talk about Book It too for a second, but to get the assessment grade in Math Lab for this, you need to get 80% or higher. So if you didn't get 80% or higher on this, you have one more chance in class tomorrow. Normally, you would take your test tomorrow, but like right after study guide day is when you take your test. But because I have that Sugo field trip, it's now moved to the day after. So you have one more chance in here tomorrow to get 80% or higher. And on your constructed response, no one has shown me their constructed response while being in here. So if you're my students, upload it to the link in Schoology for algebra. If you're not my algebra student, then you'll have to show me that it's done at 80% or higher. You should get it from your teacher. Maybe you're getting it today, who knows? But I gave it to my students yesterday, and I always have it linked at the top of Schoology for my algebra students. Oh, and then about the Book It, I understand there are some technical difficulties. I thought that I would be able to see the whole report, but if it disconnected you, it didn't show me what you got. So if you're like, I swear I had a high score, then you can come talk to me. But otherwise, I just put it in based on what I saw visually, like watching you, and from the scores that it did show me. So
Did you put it into grade?
I did, and that's why some of you do not have good grades. Also, because some of you haven't turned in your box plot foldable either.